Hello all, welcome to the episode 21st in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. The topic of this session is memory dump acquisition. The topic is big and it will be split into several parts. In the first part today, we will talk about basic techniques for process crashes. Here is the main algorithm for using various memory dumping tools and techniques. First, we need to know whether a problem process ID can be found in Task Manager. If your process disappeared from the list of running processes, then one of possible reasons is some exception that led to process crash. Today we only consider the left branch when process ID is not present. Depending on what Windows version we troubleshoot, there are two different reliable methods. If we use old operating systems such as Windows XP or Windows Server 2003, so pre-Vista, then we can use NTSD debugger to set NTSD debugger to set it to catch crash dumps. And if we use Vista, Windows 7, Windows 8, we can use the so-called local dumps register key to capture full process dumps. Actually, both methods, like NTSD and local dumps, they work on Windows 7, and we see this during demonstration. So these are different key values you need to use to set up NTSD as a default debugger. Default debugger means that when process crashes, after exception processing, if there are any unhandled exceptions, then either process itself on older Windows versions or Windows reporting process will check this register key, launch this process, which then attaches to still existing process, and you can specify what command. For example, here we dump process memory and then quit, and then process disappears. And on old operating systems such as Windows XP or Windows Server 2003, NTSD is present in Windows System 32 folder. And so if you, for example, but this is old NTSD based on old DLLs, and if you need, for example, to use better switches such as MA, for example, to capture CPU usage, then you need to install debugging tools for Windows and specify full path to new NTSD or copy NTSD to system new NTSD to system 32 folder. Please note that you need to use different NTSDs if you use 64-bit system, if you want to capture real 32-bit crash dumps and not crash dumps of 64-bit processes that emulate 32-bit application, the so-called WOW 64 mode. And local dumps is even simpler. This is for Vista, Windows 7, Windows 8. When you set up local dumps register key and names, then every time something crashes, dump will be saved there, full dump. Note that I use a special naming scheme. S means software, M means Microsoft, W means Windows. If you go back, WNT means Windows NT, and CV means current version. So let's now see that in action. So let's see all these in action. So what I do, I switch to registry. In registry, I already set up in local machine software Microsoft. This is 64-bit Windows 7. Microsoft Windows current version. Windows error reporting. It's actually Windows error reporting. And then here we have, I created a local dumps key where I put dump folder and dump type to full user dump. And I also set up register keys for NTSD just to show you how NTSD works on all the systems. These keys still work. So what we have here, again, local machine software Microsoft, Windows NT current version, and then we have this register key AE debug, and here I put a debugger. Because there's no NTSD on Windows 7 in System32, I use debugging tools for Windows. So I installed them, there is NTSD there. So I put, and I store any dumps created in NTSD dumps folder and x64 subfolder. And I also created another key, WOW6432 node, and here Microsoft Windows NT current version debug, and I put the 32-bit processes running on 64-bit Windows. I put this again NTSD, but NTSD from 32-bit debugging tools for Windows. And all dumps I hope will be saved in 86 subfolder. So this is our setup, and so now we use another program called Test Windows Error Reporting. So let's run this application. So first of all, I run 64-bit version. I push the button. And then debug. Okay, did you notice flash of console window? That was in TSD. And now, if we go to NTSD dump folder, we see there is a dump saved here by NTSD, and also in memory dumps there is nothing. That's interesting. I have to troubleshoot that. So let's then test 32-bit version of test Windows Server reporting. So I run it. Debug, but there's no flashing window. Let's check NTSD dumps. Directory is empty. Actually, to troubleshoot that, I used process monitor, and I was searching for NTSD, and I found that for 32-bit key, from 32-bit version, the value of key was read and appended to system32. Of course, this path is invalid. But for 64-bit, everything was normal. So the right NTSD was found. And so I went back and removed this full path to NTSD, but I also went to folder where 32-bit NTSD was installed and copied it to system32 folder. So, and after that, everything worked for 32-bit register key. So let's repeat now, run, then crash. You see now, we see the flash of NTSD console window, and if we go to, you see now in x86 folder, a new dump appears from 32-bit test Windows Server reporting process. Let's check memory dumps. So one dump appeared there too. So I'll troubleshoot the reason why nothing was saved in memory dumps when we crashed 64-bit test Windows error reporting. Let's double check that again. No, nothing appeared. Maybe because we pressed debug. Let's try again. But this time we don't do debug. Just close program and check. So you see we didn't do debug. So maybe because we set NTSD as a default debugger, local dumps stopped working. But now, when we didn't choose debug, but chose close program, NTSD didn't save anything, but local dumps key that setup saved the crash down. So okay, so this is all I wanted to demonstrate. Let's go back to presentation. So when you download this presentation, I put some useful links where you can find tools such as test Windows error reporting, and also download the latest versions of debugging tools for Windows. And finally, so these are useful links. And finally, we come to the usual add slide of forthcoming training sessions and free webinars. In less than 2 weeks, an accelerated Windows memory dump analysis training is starting. There are still seats available for registration. And also in April starts Live Debugging 3 training course available for booking now. And in summer we plan accelerated Windows network trace analysis training based on software trace and log analysis patterns and software narratology. And so thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. The next episode should be on the 18th of February, and we continue with memory dumping. Thank you, and bye-bye.